CNK Global, and Ahmet Berat İlhan from Havelsan. The paper will address multi-domain approach in operational level command and control information systems. Then it will be followed by Suat Dönmez, Brigadier General, retired from Istanbul Topkapı University, and he will be talking about command and control challenges in multi-domain operations. Then we will have Mesut Özel, retired Rear Admiral. He is from Kent University, and his paper will be on the evolution of the long horizon integrated maritime surveillance system, strategic advance from the homeland to the blue waters. Then Reşat Ali Tütüncüoğlu, a lead trainer, again from Havelsan, and Selda Güney from Başkent University. Their paper will be on AI-driven target detection and identification system for military combat vehicles using decision support metrics. And finally, we will have Can Demir, a PhD student from National Defense University. He will talk about the idiosyncratic and implicit adoption of the multi-domain operations concept by the Turkish military. Now we have the great pleasure of having Eray Ekin on multi-domain approach. Now the time is 15:18, and he has 12 minutes to go. Thank you.
Thank you very much, sir. Greetings from South Korea, from Seoul. Actually, Mr. Eray Ekin cannot make the presentation, so I will be giving the presentation on behalf of us.
Ahmet Berat İlhan.
Yes, sir. Thank you very much.
Can
you see the presentation? I'm broadcasting it right now.
Not yet.
Okay. Can you see
now? It's on.
Now it's on. Okay,
Thank
sir. Thank you very much. It's a privilege to give this presentation before you. My name is Ahmet Berat İlhan. I'm a retired submarine commanding officer, captain from Turkish Navy, and currently working as a concept development expert at Havelsan Underwater Directorate. I would like to introduce my co-author, Eray Ekin. He is also a retired submarine commanding officer, captain, and currently working as a multi-domain operations MDO expert at CNK Globals. As most of us are aware, wars of the last century were defined by land, sea, and air, while this century's conflicts are increasingly shaped by space, cyberspace, and disruptive technologies linking all domains, namely land, sea, air, space, and cyberspace. This shift represents not just an evolution of tactics, but a fundamental redefinition of warfare. The ongoing war in Ukraine tragically illustrates that traditional joint operations, where land, naval, and air forces work within rigid command structures, are inadequate. We now face a reality requiring agility, integration, and decision superiority across 5 domains and 3 dimensions: physical, cognitive, and virtual. Our article presents a conceptual framework for a command and control information system for multi-domain operation called BattleNet. To grasp the necessity of multi-domain operations, we must first recognize the strategic transformation reshaping warfare. We are transitioning from industrial age conflict to information age competition, where power is diffused among state, non-state, and commercial actors, all exerting strategic influence. The battle space is now transparent, instantaneous, and saturated with data, making the speed of information crucial to the speed of war. This occurs within a renewed great power competition framed by hybrid conditions, blending cyber attacks, disinformation, and electronic warfare with kinetic operations. In this context, control shifts from geography to information dominance and decision tempo. highlighting that MDO and systems like BattleNet are operational necessities rather than theoretical ambitions. History demonstrates each revolution in warfare starts with a transformation in command and control. In World War I, radio changed how commanders managed dispersed forces. World War II saw mechanization and air power significantly expand the battle space. During the Cold War, precision strikes and satellite reconnaissance redefined operational art. In the 21st century, AI, big data, and network autonomy are reshaping coordination. Just as radar influenced the Battle of Britain, drones and AI algorithms are transforming modern conflict, making multi-domain operations essential. While joint operation focused on coordination, MDO prioritized orchestration, a symphony of effects across land, sea, air, space, and cyberspace, unified through data. Before going further, let's recall the definition of MDO as stated in the NATO MDO concept 2023. The orchestration of military activities across all domains and environments, synchronized with non-military activities to enable the alliance to create converging effects at the speed of relevance. To appreciate the scale of this shift, we can construct joint operation with multi-domain operations. Joint operations focus on service-centric hierarchies, coordinating land, sea, and air under unified command, achieving cooperation sequentially with rigid structures. In contrast, MDO requires dynamic integration across all 5 domains and 3 dimensions. This shift, both quantitative and qualitative, while joint operations coordinate, MDO synchronize and orchestrate. This approach aligns closely with NATO's evolving doctrine, most notably Allied concept for MDO and cross-domain command concept, both emphasizing the fusion of military, civilian, and informational power to achieve decision superiority. In short, we are moving from combined arms to combined effects. The war in Ukraine exemplifies the shift towards MDO and serves, unfortunately, as a live testbed for its principles. 4 key lessons emerge. First, the information age, where Ukraine integrated NATO intelligence with open source data, making information a weapon as formidable as artillery. Second, communications resilience was highlighted when Russian strikes disrupted military network and Starlink provided crucial connectivity, illustrating the risk of reliance on commercial platforms. Third, targeting and fires. The ARTA system and Uber for artillery enabled real-time connections between drones, observers, and artillery, leading to quicker targeting and higher operational tempo. Finally, drone proliferation transformed warfare with over 6,000 drones in the first year of the war only, making advanced capabilities accessible to every soldier. Ukraine shows that MDO is not just a future concept, but a current reality presenting both opportunities and vulnerabilities. These advancements are driven by NATO's emerging and disruptive technologies, EDTs. Artificial intelligence and machine learning facilitate real-time data fusion and predictive analysis. Big data and cloud infrastructures enable swift aggregation of battlefield information from diverse sources. Drones and robotics enhance operational reach while minimizing personal risk. Cyber and electronic warfare influence the information domain by disrupting command networks. Space assets, like satellites and sensors, underpin global connectivity. Collectively, these technologies form the BattleNet ecosystem, a digital nervous system transforming data into actionable decisions and effects. The focus of today's discussion, BattleNet, envisioned as a system of systems that enables seamless interaction between military and civilian systems for unified situational awareness and decision support. It's built on 4 pillars: orchestration for real-time coordination across all 5 domains, synchronization for aligning military actions with civilian and industrial resources, system of systems, interoperability for connecting legacy systems with modern architectures, decision support and autonomy, leveraging AI and data-driven recommendations. Battle.net integrates sensors and decisions tools to create a unified command picture, serving as the digital headquarters of MDO. To illustrate Battle.net in action, consider a scenario where a commander is tasked by Battle.net with neutralizing a hostile logistic vessel. Note that this task is decided and approved by human commanders. Battle.net quickly analyzes assets across land, sea, air, cyber, and space, identifying the best combination of military units while integrating civilian logistics and satellite intelligence. Real-time recommendations inform which unit to deploy, drone to launch, and satellite to queue. Within minutes, the operation is validated and executed across multiple domains. This results in reduced latency, optimized resource utilization, and accelerated operational tempo, showcasing orchestration and synchronization as a demonstration of decision superiority. No concept, no matter how well designed, is free from real-world constraints. For Battle.net, 3 primary challenges emerge. Interoperability involves the complex integration of legacy systems, allied platforms, and commercial technologies requiring cultural and technical adaptations, despite standards like Federal Mission Network, FMN, and Multilateral Interoperability Protocols, MIP. Cyber resilience becomes critical as a larger network increases vulnerability and cyber attacks, necessitating redundancy, layered defenses, and quick recovery capabilities. Lastly, the human factor emphasizes the need to train commanders and operators in network thinking, ensuring they grasp the interconnections between domains. Ultimately, success in NDO relies in cognitive power, humans and machines reasoning collaboratively at speed. Ladies and gentlemen, 21st century has introduced a new era of conflict, characterized by multi-domain, multi-actor, and multi-dimensional dynamics. Lessons from Ukraine, the rise of disruptive technologies, and the integration of civilian and military power indicate a future where command is interconnected. Battle.net serves as a blueprint for this future, merging technology, doctrine, and national will into united command structure that adapts swiftly. Our challenge lies not in whether to build it, but in how to do so securely, interoperably, and inclusively. As victory will favor the most connected, not to the strongest. That concludes my briefing, sir. Thank you very much for listening.
Thank you. Just on time. Thank you. Excellent. Thank you.
Thank you very much.
Thank you very
sir.
much.
Appreciate that. Thank you.
And
If you have any
now,
questions, okay, maybe later. Okay, so
perhaps at the end, perhaps. Thank you.
okay, sir.
Then we have retired Brigadier General Suat Dönmez, who will be again talking about command and control challenges in multi-domain operations. In a sense, this will be a continuation of the presentation or address we've just heard. General, floor is yours. Do we have Suat Dönmez with us?
Sesi kapalı.
Okay, thank you, sir. I think.
Thank you.
The mic is on.
Please go ahead.
So, good afternoon, everyone. I'm Suat Dönmez, a retired Brigadier General and Associated Professor at Topkapı University. So I'll be talking about command and control challenges in multi-domain operations. Okay, since the end of World War II, the world has not experienced a major global conflict. Instead, the international system has been shaped by intrastate wars, proxy conflicts, and involvement of external powers. However, rising strategic competition, economic and political tensions, and technological advances now raise the question of whether this period is coming to an end. Today's security landscape is becoming more complex. Hybrid strategies, information operations, and cyber attacks, they all blur the lines between war and peace. And the battle space has become highly active, urbanized, and interconnected, where adversaries challenge forces across all domains and levels of command. And warfare is experiencing another military revolution, driven by the interactions of technological innovations and human adaptability. While technology expands possibilities for precision, speed, and situational awareness, the human element, especially the judgment and decision-making, remains an essential factor. The persistent fog of war requires strong situational awareness, fueled by connectivity, space-based assets, and real-time data integration. New systems such as robotics, autonomous platforms, and network-enabled weapons are transforming how operations are conducted. At the same time, artificial intelligence, AI, is transforming command and control, improving the speed and quality of decisions across the forces. These developments altogether, they converge in the concept of multi-domain operations, a comprehensive approach for coordinating capabilities across land, sea, air, space, and cyberspace to gain operational advantage. The multi-domain operations is not just about acquiring new tools, but it also represents a new way of thinking about actions, effects, and integrations. For example, the NATO alliance, it's interpreted, the multi-domain operation in NATO is interpreted as different depending on the expectations, like among the military and academic circles, but it reflects its changing and complex nature of warfare. As the NATO Command and Control Center of Excellence highlights, MDO should be seen as a conceptual shift, not only a technological one, an evolution in how forces think, connect, and operate together across all domains. In a time of increasing instability, MDO represents the alliance efforts to adapt to a boundaryless, fast-changing, multi-domain battle space where technology and human decision-making together determine success in future conflicts. The future operational concept must enable military forces to execute their core tasks across the entire spectrum, from peace to conflict, under all conditions. So to do so, it's necessary to continuously assess the evolving strategic environment and adopt strategies to maintain operational advantage. It became evident that this MDO approach can be achieved by going beyond the traditional joint concept. In its current form, joint operations do not allow for the timely generation of sufficient effects and for presenting adversaries with the necessary range of dilemmas, unless a comprehensive and structured response is activated. The only way to overcome these limitations is to prepare, plan, coordinate, and execute synchronized actions rapidly and at a scale across all domains and environments, in close cooperation with other instruments of power and the strategic partners, of course. The ongoing Russia-Ukraine war has emphasized that the critical need to operate effectively across all domains, especially cyberspace and space. The conflict has shown the vital importance of drones, autonomous systems, and digital connectivity in shaping modern battle space. It has also highlighted the increasing need for adaptable leaders who can quickly produce coordinated effects at scale across all multiple domains. More broadly, the conflict illustrates the increasing need to orchestrate military operations and integrate non-military instruments of power, such as information, diplomacy, and economic measures at the space of relevance. In a highly dynamic security environment, effective multi-domain synchronization is no longer optional. It is fundamental to achieving strategic advantage and operational successes. As for the assumptions for the future-oriented cognitive systems and commands, I can say, especially for the future command and control systems, environment will be definitely increasingly complex and mission-critical, requiring constant vigilance and high situational awareness. Decision makers will operate within ongoing uncertainty, risks, time pressure, and resource limitation, which necessitates quick and well-informed judgments. The mission environment will be highly dynamic and non-linear, where even small actions or decisions can lead to serious and irreversible consequences. Success in such conditions will depend on comprehensive operational awareness, the ability to interpret data, generate context, and then turn information into actionable insights. Additionally, mission effectiveness will rely on collaboration across diverse organizational culture, integrating individuals with different backgrounds and expertise, and ensuring seamless interaction between human operators and autonomous intelligence systems. Sustaining human-machine collaboration and operational readiness will be the key for the success for the future command and control systems. Why do we need the change for the C2? I mean, the changing nature of warfare definitely requires the transformation of command and control systems. What is needed is multi-domain command and control systems, which means the ability to seamlessly analyze, integrate, and share information that was previously limited to individual sources or domains. The multi-domain C2 aims to create a cyber-secure, flexible systems that integrates shared data across all domains, from sensors to decision makers, enabling synchronized actions at every level of conflict. However, cyber and space domains present new challenges to traditional C2 systems. Effective integration with land, air, and maritime operation requires strong inter-domain coordination and understanding. Both domains also experience rapid technological changes, making doctrines and systems quickly outdated. Additionally, the large volume of data generated in these areas complicates timely and informed decision-making. Addressing these challenges will require ongoing investment in training, technology, doctrine, development, and international cooperation. So the new C2 network, a new operating concept, requires a corresponding new joint command and control structure. The future C2 frameworks must rely on secure, reliable, and cost-effective communication systems that can integrate platform sensors, data streams, operators, and decision makers, including the weapon systems, of course, within a contested electronic warfare environment where lethal and non-lethal, whether lethal or non-lethal. This transformation requires a more advanced data exchange system than the current reliance on formatted messages. Therefore, it is essential to design a completely new network or significantly upgrade the existing systems. Many of today's communication frameworks are technologically outdated, which hinders interoperability, and also responsiveness, timely. The main challenge is to create a joint multi-domain and comprehensive C2 approach that functions across services and domains command levels and instruments of power while effectively involving external stakeholders. Supported by digital transformation, this network must ensure sensor-to-shooter integration, providing the agility and connectivity needed for the future operations. Effective command and control in multi-domain operations relies actually on 4 independent functions. The first one is situational awareness. So it's continuous sensing, fusion, and sharing information to build common operational picture. Situational awareness must combine data from all domains, filter out noise, and provide timely and relevant context to the leaders and systems so they can understand the environment and emerging threats. The second one is operational decision making. It's the process of turning situational insight into actionable steps under uncertainty and time pressure. The function combines human judgment, doctrine, and AI-enabled decision support to set priorities, allocate limited resources, and weigh risks against opportunities. A third one is battle management. It's the coordination of assets and effects to carry out selected courses of actions. It transforms decision into coordinated multi-domain operations, assigning sensors and shooters, sequencing files, and non-kinetic effects, and adjusting plans in near real-time reach desired operational result. The fourth one is the force direction. It's the official assignment of missions, responsibilities, and rules of engagement among commands. Force direction really clarifies intent, establishes supporting command relationships, delegates authority, and so on. So altogether, these functions create a continuous cycle. Situational awareness informs decisions, decisions influence battle management demands clear force direction, and force direction guides the sensing posture, enabling resilient, rapid, and coherent C2 in tomorrow's multi-domain battlefield. As for the conclusion, I can say that mastering all 5 domains and successfully integrating emerging ones, it remains a major challenge for us for the future. This transformation isn't just about technology. It requires a dual approach that combines technological innovation with cognitive and human adaptation. The shift demands moving beyond traditional systems and mindsets toward a future-focused strategy that embraces complexity, connectivity, and speed. Connected networks, informed decision-making, and the ability to act quickly are crucial for leveraging both current and emerging technologies in multi-domain operations. The need for effective multi-domain C2 is therefore urgent and evident. While it took once more than 2 generations to establish a true joint culture, we no longer have that luxury. We may never fully eliminate the fog and uncertainty of war as Karl von Clausewitz described. However, with a well-designed and implemented MDC2 systems, our commanders will have a clearer picture and shift the fog and uncertainty to our adversaries. Thank you very much for listening.
Thank you. Thank you very much indeed. Thank you. Thank you. So we leave questions, if there are any, to the end of the session. Now we will have Rear Admiral Mesut Özel, who will be talking about the evolution of the Long Horizon Integrated Maritime Surveillance System, strategic advance from the homeland to the blue waters. Dear Admiral, it's all yours now. Please go ahead.
Thank you. Good afternoon. I'm Admiral Mesut Özel. I'm Assistant Professor of International Relations in Istanbul Kent University. I salute you all with great respect, and I also would like to extend my gratitude to the organizers for this exclusive event. Today, I'll be presenting on a compelling case study in modern naval strategy: the evolution of Turkey's Long Horizon Integrated maritime surveillance system. This presentation will trace the system's journey from a localized tactical solution to a cornerstone of national power projection, a journey that offers critical insights into 21st century maritime power. Okay. The story of Long Horizon begins with a clear, pressing strategic problem: the Greek islands in the Aegean. Those islands provides Greece a geographic and strategic advantage, and this creates a significant surveillance and targeting asymmetry. Furthermore, the advent of long-range guided missiles meant a ship's own radar could no longer see far enough to use its weapons effectively. So, the Turkish Navy needed to see beyond the horizon. Our central argument today is that the Long Horizon project was never just about solving this immediate Aegean problem. It strategically evolved to become the very nervous system of the modern Turkish Navy, enabling its decisive shift from coastal defense to open ocean operations, all while achieving a remarkable degree of technological independence. So, how did they build such a complex system? A key to its success was the innovative evolutionary procurement model. Instead of a single high-risk Big Bang project, it was broken into manageable phases. This started with a core capability, a basic surveillance network covering Aegean. This was then enhanced with new platforms and sensors in a second phase. Finally, it matured into its final configuration, fully integrated with national command systems. This phased approach was brilliant. It allowed the Navy to field capabilities quickly, learn from real-world use, and adapt to new technologies. A crucial lesson for any complex defense project. Now let's look at what this system actually comprises. It's truly a system of systems. It pulls data from a diverse array of sensors, from coastal radars, maritime patrol aircraft, unmanned aerial vehicles, electronic support measures, and you can add many to that. And all these data flows into regional and main fusion centers. Actually, our main fusion center is in Izmir. This is where the magic happens. Raw data is correlated and fused into a single coherent, recognized maritime picture, or we can just say it, tactical pictures. This crystal clear picture is then distributed in near real time via secure data links to everyone who needs it, from ship captains to operational commanders, enabling perfectly synchronized action. Perhaps the most significant outcome of Long Horizon was not just the system itself, but the sovereign technological capability it spawned. Under the Navy's leadership, actually, it started with a joint project with the Istanbul Technical University, but it didn't work out. So Navy established a special unit for it, which is our Research and Development Command, spearheaded the development of indigenous advanced combat management system. The strategic genius of Advent is its commonality. It's not just for ships. It's the core system for surface vessels with Genesis, for submarines with Muren, and for aircraft with Martı, and we will now apply it to Long Horizon as well. This drastically improves interoperability and reduces costs. And this shift from foreign dependency to national sovereignty in its core combat software is arguably the project's most profound outcome. So this system expanded. It was first aimed to cover Aegean. Then, because of the needs after the 9/11 events, all international society focused on maritime security. So we need to what's happening on the seas. So there was quite a need to have a white picture. We call it white picture, the movement of civilian ships. With the technology maturing, the system roles began to expand dramatically. And the Navy launched for this purpose Operation Black Sea Harmony in 2004. Otherwise, United States, in the squeeze of NATO, would like to get into Black Sea. So we created a regional picture and shared it with NATO. Similarly, after the inauguration of Bakü-Tbilisi-Ceyhan pipeline, Operation Mediterranean Shield was initiated in 2006 to secure critical energy routes from the Ceyhan pipeline. Crucially, during this phase, Long Horizon began fusing military data with information from civilian authorities, the Coast Guard, port authorities, and fisheries, and many others. This created a comprehensive white picture of all maritime activity, turning it from a purely military asset into a vital tool for national security. So, along with projecting power into high seas, the system also had a reach globally. As Turkish Navy began operating far beyond its home waters, from anti-piracy operations in Gulf of Aden to NATO exercises in the Atlantic and Arctic, the Long Horizon expanded with the platforms operating in these areas. Its coverage expanded from the Aegean to the Black Sea and Eastern Mediterranean, and ultimately to the Indian Ocean, the Atlantic, and the Arctic. Through satellite links, the recognized maritime picture from waters around Turkey can be shared with the task force on the other side of the world. The system is no longer just about defending the homeland. It's the key enabler for power projection on the global side. So, what are the tangible returns on this decades-long investment? In short, Long Horizon is a classic force multiplier, as stated by Admiral Güven Arkaya at the beginning. Militarily, it allows for the effective use of expensive, long-range weapons and provides a decisive information advantage in combat. For national security, it safeguards our economy by protecting energy lines and trade, while also enhancing capabilities in areas like counter-smuggling and search and rescue. The benefits, therefore, extend far beyond the battlefield, delivering value across the entire spectrum of national security and economic interests. In conclusion, the story of Long Horizon is one of the visionary strategy and successful adaptation. It successfully transformed a tactical need in the Aegean to a strategic capability that underpins Turkey's status as a rising maritime power. Ultimately, Long Horizon has not only met operational needs, but has fundamentally shaped the Navy's strategic thinking to see over the horizon. It's the central nervous system that makes the Blue Waters Doctrine a reality, proving that visionary investment in C4ISR can truly redefine a nation's place in the world. And this concludes my briefing. I would like to thank you all for your attention. I would be happy to answer any questions that you may have. Thank you.
Thank you. Thank you very much. Good to see you, Admiral.
Thank you.
Please pass our best regards to our friends in Kent University. Thank you.
Okay.
Now we will have Reşat Ali Tütüncüoğlu or Selda Güney. Who will be talking to
Yeah,
us?
sure. This is me, Reşat Ali Tütüncüoğlu
Okay.
from Havelsan.
Excellent.
At the moment, I think Rear Admiral Mesut Özal's presentation is on. Is it possible to close it?
I am trying to do that. Technology.
My name is Reşat Ali Tütüncüoğlu. I am the retired colonel from the Turkish Land Forces, and now I am working as a lead trainer in the Havelsan for the Command and Control Systems department. And if possible, let me try myself to share.
Yeah, please.
Yeah. I think.
Okay. I think I did it.
Yeah.
Okay.
Thank you. Thanks, sir. Let me
We
try
see
to
you.
open my thoughts.
Yes.
Yeah. Sorry for the delay.
At some stage, we saw northern lights. Which was beautiful.
This was not my computer, sir.
Okay.
Entire screen. It is opening the Chrome tab window. It doesn't apply. One more time. Yes. I think now it can be seeable.
Yes. Yes. It's
Your
on now
permission,
and
sir.
perfect.
Okay. I am beginning my presentation. Together with Associated Professor Selda Güney, we prefer a study with my doctoral studies. Our subject was AI-driven target detection and identification system for military combat vehicles using decision support matrix. And I will present my presentation in this contents: introduction, methodology, conducted studies, target detection and identification system that we have created, and a conclusion. As an introduction, as all we know, the military operations represent struggles aimed at changing an opponent's behavior and imposing one's will on another. These struggles are conducted in a dynamic and insecure operational environment to meet the political objectives of the relevant international actor. In this context, decision makers develop a plan to facilitate coherent and synchronized military operations whose impact will shape mission, success, and overall achievement. There are 4 activities necessary to conduct military operations: planning, preparation, execution, and continuous evaluation. All of these activities are interconnected and interrelated. It is absolutely necessary to implement a set of integrative processes and activities whose results and products support the efficiency of the activities mentioned. And one of the most important subjects is the target management process. In the realm of modern military intelligence, the advancement of combat vehicle type classification technology is vital, especially for ground forces. Understanding the capabilities and the limitations of these vehicles serves as a cornerstone for effective military tactics and strategies. The classification of combat vehicles, encompassing their identification and analysis on the battlefield, is essential for target prioritization, tactical decision-making, and operational effectiveness. Basically, military target management includes the following steps. The first step is the detection of the military targets, then identification. It should be recognizing and correctly classifying of the targets, then monitoring the military targets and direct the targets appropriately. The complexity and the dynamic nature of military operations necessitate effective target management and strategic planning. The success of these processes depends on accurately directing the opponent's behavior and achieving strategic objectives. Advanced information technologies and artificial intelligence applications have enabled significant change in the battlefield. In our study, we created methodology by using the AI-driven technology. Our study highlights the implementation of AI-driven classification technology, specifically utilizing the YOLO version 8 model, which demonstrates significant advantages in image processing and object detection. By providing real-time detections with high accuracy, this model assists operational personnel in making informed decisions while minimizing risks. On the presentation, you can see our target detection and identification system methodology. First, we are entering to the image of the vehicles. This can be a live camera or a picture that is coming from another source. So there is a one-stage detector we call the YOLO, you look only once, and it is added another algorithm which we call the secuse and extinguishing. So by getting the information of the identification, we are measuring the distance by using the specifications of the vehicles. So we are dividing into 3 categories by short, medium, and long. And by using the decision support matrices, we are making a prediction for the type of countermeasures, basically. And at the moment, you can see our classified types. Actually, we selected the 7 types that are used mainly on the land forces of the European countries and the GCC countries. And when we look to the test results, we didn't make our test and improvements only by using the YOLO 8M. We tested by the different algorithms that can be seen on the table. YOLO version 8 medium performance results were compared with other YOLO versions. YOLO version 8's average accuracy of 83.6% and the detection rate of 117 frames per second, compared to other versions, demonstrated significant advantages in terms of accuracy and speed. The reason why is advanced spine and neck structures and features such as the mosaic data augmentation were effective in increasing both prediction, accuracy, and processing speed. Data-based performance analysis demonstrate YOLO version 8 superior performance, demonstrating the consistency and reproducibility of the overall results. And also, we didn't stop by only using the YOLO algorithm. We added another improvement, which we called secuse and extinguishing module, to increase the channel attention and to progress the model's representativeness. And this model is added to each convolution block of the YOLO. Sorry for a little bit technical at this moment, but the results will helpful at the end. And this allowed the network to prioritize more critical channels, reduce the contribution of necessary channels, and achieved better discriminatory features. As you can see on the table, average accuracy increased by almost 5.7%, and also there's a big significant improvement gained by the detection rate. And now you are seeing that our target detection and identification system, human-machine interface. After we improved our system with the software addings, our system has a capable to upload image or start a live camera, which we aim to use the armored personnel carriers electro-optical devices. The system immediately giving a target information and making a recommendation by using the decision support matrices. And here is one of the example. When we upload a picture, automatically it is detecting the type of the class, height, distance, and it is making a recommendation. On the bottom table, you can see the real data test that is done on the field. And almost the test results are similar to the laboratory test results. Also, this is another an application that is automatically says that the armored vehicles immediately and making a recommendation. As a conclusion, this study developed a target detection and identification system for tactical land force units, incorporating pre-processing, segmentation, classification, and transfer learning steps, while also providing actionable recommendations through a decision support matrix. The ability to operate efficiently in varied conditions not only increases the utility of the technology in a real-world scenarios, but also strengthens the military's adaptive strategies. Additionally, feature studies tailored to low light or night vision conditions could enhance this system's capabilities. Conducting research under these specific constraints will allow for the refinement of algorithms and improve accuracy, and ensuring that classification remains effective even in a challenging environments. And sir, that concludes my presentation. If you have questions, I can answer.
Thank you. Thank you. Excellent. We leave all questions to the end of the session. If there will be any, we will see it. Thank you. Excellent. Excellent.
Okay, sir. Thank you.
Thanks. Now we have the final presentation of this session by Can Demir. He's a PhD student in National Defense University. The subject is the idiosyncratic and implicit adoption of the multi-domain operations concept by the Turkish military. Very interesting title, idiosyncratic and implicit. Looking forward to hear your views. Do we have Can Demir with us? Are we missing Can Demir? I'm afraid we do.
Yes, we cannot see his name on the among the participants. Sure. Possibly he hasn't attended.
But he was planned, right, Can Demir? But he's not online.
Yes, maybe not online, but he has been. He's absent now, but maybe he missed the time or something else.
Okay. Then we have almost 20 minutes. What about questions you may have to the presenters? Are there any questions? Otherwise, I will share my final thoughts in a few sentences. Then we will adjourn the webinar today. Any questions?
Third, there are some, comments or idea or the question in the chat. If you look at the chat, I think UK, what is UK? Umut. I think he has some idea or the question, and also Umut can ask. Mr. Umut. Yes, he has some idea there, on the trade-off between using civilian sensory information, and there is an obvious place of
I
this
think
data in the yes.
It was an input provided before the presentation, then after. There's an obvious trade-off between using civilian sensor information, and there's an obvious place of this data in the MDO environment, multi-domain environment. Where should the line be drawn between public safety and public information privacy? I'd love to hear the expert's opinion on this.
Sir,
Do we
this is
have
Ahmet
it
Berat İlhan.
correctly?
I think I can answer the question, actually, sir.
This is for Ahmet Berat Bey. Yes, please go ahead.
Sir, the thing is, I mean, as I mentioned, the BattleNet, it's like here, Mr. Umut asked for if civilian sensor information can be used. As I mentioned during my presentation, the Ukrainian Artillery Service, ARTA, actually it is GIS ARTA, and Art of Artillery, it's the short version. So they are using literally for this information from YouTube, from Snapshot, any civilian, any Ukrainian saw a Russian tank or Russian unit, and it just, they took the photo, send it to via cloud system, direct message. They upload it to the ARTA system, and the artillery, even without giving the geographic position, it just looking and detecting from the geographical obsolets and beacons. They detect the exact position of the target, and they fire and concentrate on that target. What we are talking about is actually the BattleNet itself. It looks like a futuristic, very futuristic approach, but think about like Uber. I don't know how many of you are using Uber. It's a taxi calling service.
Many of us.
Okay, so here is the basic idea that imagine that if joint warfare is calling a taxi stop and asking for a taxi to your door, Uber is multi-domain operation. The idea is you have so many resources and you have so many requests. Matching those requests with resources is the key. And these resources are not necessarily be part of any specific command or army. For example, if army needs a helicopter, rotary wing, or any other unit, if the Navy has it, without any hierarchy, without any sequential coordination, they will ask for the command, the other one goes and up, all of a sudden, instantly, that demand will be satisfied by the available resource. It may sound a little bit difficult, for instance, but I mean, 10 years ago, it's the same if you were thinking calling a taxi in any place in the world. You can just take it and use it. The technology is available for us, but as mentioned later after my presentation, the human factor is emphasized, is the key, because it is the conceptual paradigm shift. If we can adopt this, the ones who adapt will survive, actually. It's like a huge Amazon in the movie, just for the application. 3 million people are watching Amazon, the same movie, in 1 second, actually. There's a huge storage for that. Of course, we are talking about the challenges of it. There are many challenges we accept, but the technology is there, and cope with technology, cope with those challenges is our hand, actually, I should say. And this question is definitely we need such any information. This is what is called big data. And now the command systems, information systems, they used to be just situational awareness. Their job was to give the whole picture. Now their job is to give decision aid. making data as a decision aid. So the more the data, the better the decisions are. And the interconnections and correlations and relationship between those data, the anomalies of that data gives the key and the decision support. No human can manage to consume that data and come to the conclusion and catch those relationships, patterns, without the machine helps, unfortunately. So this is the idea, and using even a dog, I mean, colors, video camera, civilian people use it a lot. That dog is walking and you get all the information there. The micro UUVs, UAVs, anything you can think of. This is a huge thing, but actually it's coming from civilian side, not from the defense side. Uber is a vehicle routing problem optimization, basically goes back into 1950s. My master degree is in operation research, and my thesis was vehicle routing problem. And I was amazed when I see the Uber algorithm. It was very wisely think, but taking the big data and AI and optimization tools, they managed to do this. Once you call an Uber, the taxi driver must have a clear jurisdiction paper, sabıka kaydı. He shouldn't. The car has to be a valid TÜV, car inspection checked. Many other things that they have to qualify this. They are matching with our vision for the BattleNet actually. And the big data storage is the cloud, and the Amazon already made it 10 years ago. And as defense, we are going a little bit late actually. Civilian side is more faster actually. Sorry. Yes, sir. That's all.
Thank you. Thank you very much. Any other questions? Okay. Then, while listening to our distinguished presenters, I took a few notes. I would like to share them with you and then adjourn the session. About the kind of transformation from joint operations to multi-domain operations. I think we all agree that this is not like, day and night. There's a twilight zone, twilight time. So this is not an abrupt transformation. Perhaps even it's not transformation from one realm to another. Perhaps it's just incorporation of space and cyber into our traditional joint operations realm. In that sense, perhaps we are just at some stage today. I had the chance to listen to a presentation on Clausewitz. I think the basic nature of warfare or combat did not change a lot. Perhaps it's a constant. You use whatever you have in your control to defeat your adversary. So the new technology or developing technology is just offering us new abilities, new capabilities, or just improve our already existing capabilities. So in that sense, for example, artificial intelligence, cloud, emerging technologies, disruptive technology, etc., they're just being added into our already existing capabilities, improving our combat prowess. Perhaps in that sense, what we need to do is to focus on how to manage this transformation process. What I mean is that, what we call doctrine is actually the way we intend to fight the war. So in order to reach this stage of doctrinization, we start from a concept. So perhaps what we need to do right now is to incorporate new technologies, some of which we've just heard about, into our current doctrine, and then turn it into a conceptual framework, tested first in academic studies like we are doing right now, and then perhaps tabletop exercises, and then field exercises, and then just test it in actual day-to-day combat missions, and then turn it into doctrine. But perhaps what we generally miss is that at the end of the day, it's not about a new combat culture, but it's also about a new structure, a new organization. So it's in a multi-domain operations, we need a new battle structure, a new military organization, top down. And perhaps we miss this. We miss this. To be honest, we in Turkish context, we've been missing this since the end of the Second World War. If we look at our current organizations, military organizations, from the general staff to armies to corps level and down, we are still stuck in the old, service-centric approach, not only in terms of culture, not only in terms of our approach to combat or war fighting, but also clearly reflected in our organization. Now we understand that reviewing our organization, and finally, after about 75 years since the Second World War, look for ways as soon as possible to adapt ourselves into this new so-called multi-domain operations, perhaps a new term replacing joint operations. I don't want to intend to take longer of your time. Personally, I learned a lot, and I appreciate all our five presenters, perhaps four. We missed one. And I congratulate them in such a short time, summarizing so important, so delicate information with us. Thank you very much. Thank you all, and I wish you an enjoyable evening. See you tomorrow morning. Thank you.
Thank you very much.
Thank you.
Sir, just one addition, if you permit, sir. Just one addition. The
Please,
difference
of course.
is, I like to just emphasize this, that it is the delta T, time curve. The action, as you said, since ages, for hundreds of years, the war has the same structure. But here with multi-domain, the ODA circle, observe, orient, decide, act, ODA cycle, was turning very slowly, actually. It was taking by hours, by days, maybe by weeks for the level of the thing. But now we are talking about a spin. The frequency is so increased. Now we are talking about decimal seconds, or minutes are too long. Even though this is where most people say, okay, we are doing surface warfare. We have been doing that, they are saying. But the idea is that surface warfare is now starting and finishing in a split second. The decisions, the data, everything is coming, and whatever the thing is, the delta T is getting shortened and shortened from the decimal, from hours, days to milliseconds. This is the maybe another big difference, I could say. Thank you very much.
Sure. Thank you. Thank you. Thank you.
Short, can I have short input on it? Excuse me, Aldon? Do you hear me?
Lazım? Yeah. Yes, please.
Lazım.
Please
Yeah.
go ahead. Please, please.
Yeah, my internet is off right now. I'm using, the telephone. Just, the short input. As I understand after the presentation, command and control is getting more and more complicated. And you talk about, the change of organization. As the U.S. Army had before, like, the embedded reporters, do you think, do we have embedded civilian technicians in the Army to deal with all these, the systems?
Is this to? Yes.
We have to employ, the civilians more than, the before to use all these, the technological, the systems in the Army.
Perhaps the best solution is to have them integrated within the military system. Then perhaps we wouldn't call them civilians, but perhaps technicians, and perhaps we already have some of them. Because I think this is not something you can get from outside the structure. If anything, just because of classification requirements or needs of the ongoing operations. So this obviously this requires a fundamental transformation of the army culture. I mean, this cannot be done through our usual military training and education system. They have to be brought from outside the army structure, but I believe they have to be integrated, firmly integrated within the system for good. Thank you.